Lesson 33. Find a line of symmetry. Study the example showing how to find a line of symmetry, then solve problems 1 through 5. Example: which shape has more lines of symmetry? So before we look at those examples, let's look at the definition of a line of symmetry. A line of symmetry is a line dividing a shape into two matching parts. So this shape has the line of symmetry going through the center in that direction, or up and down. So if you took this shape and folded the top part over to the bottom part, they would match up perfectly. And if you took this one and folded this side over to that side, that would match up perfectly. So you want it to match up perfectly for it to be a line of symmetry. The question was, which shape has more lines of symmetry, rectangle, an equilateral triangle, or a square? So we see the rectangle, and it's drawn out the lines of symmetry. There's two for that shape. This triangle, it can be folded in 3 different ways. It can be folded diagonally in both directions and straight down the center. So it has 3 lines of symmetry. And a square has 4 lines of symmetry. So it can be folded diagonally in both directions or across the middle in 2 directions also. So it has 4 lines of symmetry. Number 1 says, circle the shapes below that have at least 1 line of symmetry. So this first shape, a lot of people may think that you can fold it down the middle, but you can see that those 2 sides would not match up. And the same for going across in the other direction. If you folded that, those would not match up either. So that one does not have a line of symmetry. For this shape, if you were to fold it down the center, each side mirrors one another, or they're the exact same on each side. So that means that that would be a line of symmetry. So we know this one does have at least 1 line of symmetry. For the next shape, this triangle, if it were to be folded across the center in either direction, the 2 sides would not match up. Like you can see up here, lines of symmetry don't always have to go straight across. They could go diagonally, but even still, if you were to fold that one diagonally, the sides wouldn't be the same. For this last shape, there is no symmetry if you were to fold it in that direction or down the center. And if you try it diagonally, you can still see that the 2 sides of that line are not the same, or they are not identical. Number 2 says, circle the shape below that has a greater number of lines of symmetry. So for this first shape, if you were to fold it down the center, you can see that each side is the same. So that is 1 line of symmetry. If you were to fold it across in the other direction, the top and bottom would not match. And it also wouldn't match if you were to fold it diagonally. The sides wouldn't be the same. So this shape has that 1 line of symmetry. Now for this rectangle, you could fold it down the center in that direction and each side is identical or the same. So that's 1 line of symmetry. And then you could also fold it across horizontally, and that's the 2nd line of symmetry. So this shape, the rectangle, has a greater number of lines of symmetry because it has 2 where this shape has 1. Number 3, circle the shapes below that have exactly 4 lines of symmetry. So starting with this first shape, 1 line of symmetry goes straight down the center. You can see both sides are identical, so that's 1 line of symmetry. Another line of symmetry would go straight across the center in the other direction. You can see the top and bottom would be the same, so that's 2 lines of symmetry. Then it may be a little bit easier to see this one if you turn your paper, and you can see where straight across the center of that shape in that direction, the top and the bottom are the same. So if you're looking at it like this, it's just cutting across the center at a diagonal. And then you could also cut across the center in this direction, and you can see that both sides are the same on each side of that line. So this shape does have 4 lines of symmetry. So we're going to circle that one. Now, this next shape, this is a rectangle, and we've looked at a rectangle already. So say you wanted to fold the shape in this direction. These two sides, although they look the same, if you were to fold them over, those corners would not match or not meet at the same part. So that tells us this line is not a line of symmetry. So with a rectangle, you wouldn't be able to fold it diagonally and get a line of symmetry. So this line, it does not count. With a rectangle, you do have 2 lines of symmetry though. If you fold the rectangle down the center vertically, the 2 sides match up. So there's 1 line of symmetry. And then if you were to fold the rectangle across horizontally, the top and bottom would match in that direction also. So there's the 2 lines of symmetry. But because you can't fold this one diagonally, you only have those 2 lines of symmetry. And remember, we're only going to circle a shape if it has 4 lines, so we wouldn't circle this one. The next shape has 1 line of symmetry that goes straight down the center. You can see these 2 sides are identical, and they would match if they were folded over to each side. There's another line of symmetry across the center in that direction. So you can see the top and the bottom, they match. And then if you were to fold this diagonally, this side of that diagonal line and this side of that diagonal line, those 2 sides match. So that would be a line of symmetry. And then the same going in the opposite direction, each side of that shape are the same when the line goes diagonally in that direction. So this shape also has 4 lines of symmetry. For this last shape, if you were to fold it straight down the center, you can see that each side is the same, so that would be a line of symmetry. You wouldn't be able to fold it top to bottom. You can see the top does not match the bottom, so that is not a line of symmetry. And then diagonally, if you were to look at the shape in this direction, so you can see diagonally you do have matching sides for this shape. And most of the time, if it's going to match diagonally in one direction, it will probably match or be symmetrical in the other direction. So if we look at it from this point, you can see this side of that line, and this side of that line. Now, we won't circle this one because it doesn't have 4 lines of symmetry though. Remember, it has to have a total of 4. Number 4, look at the rectangle in problem 3. How many lines of symmetry does it have? So we drew out our lines of symmetry for this rectangle right here, and we found that it has 2 lines of symmetry. So the answer would be 2 lines of symmetry. And then we would be able to explain that by saying if the rectangle were a piece of paper and you fold the top to the bottom horizontally, so that's going in this direction across, the top and bottom would match. They would be identical. And then if you were to fold the paper vertically through that middle line, the sides would also match and be identical. So that's 2 lines of symmetry. Number 5, choose yes or no to tell whether the line drawn on each block letter is a line of symmetry. A is the letter G. So look at the line that's drawn through the middle. If the top and bottom are identical, then it is a line of symmetry. But the top and the bottom of this letter are not identical, so it is not a line of symmetry. Letter B is the letter A. So look at that line that's going down the center and look at what's on each side of that line. If the same thing is on each side of the line and it matches perfectly, then it is a line of symmetry. And in this case, it does. So the answer here is yes. For the letter C, we've got the letter M to look at. Look at that line going down the center and then look at what's on each side of that line. If it's identical and the same exact thing, then this is a line of symmetry, and the answer is yes. And lastly, for the letter D, we look at the letter E, and the line of symmetry goes across this letter E. So look at the top and bottom. If these two parts are identical or the same, that's a line of symmetry. And they are the same, so the answer here would be yes. This says to study the example showing how to draw a line of symmetry, then solve problems 1 through 5. The example says, draw all of the lines of symmetry for each star shape. How many lines of symmetry does each shape have? Where do all the lines of symmetry cross? So you see this star, and it's a 6-pointed star because it has the 6 points, 1, 2, 3, 4, 5, and 6. And then the lines of symmetry are already drawn in there. The question says, where do they cross? So if you were to trace these lines, they all are going to cross at some point, and they actually all meet or they all cross at the same point. And you can see that point where every one of those lines goes through is the center point of the shape. All lines of symmetry cross at the center point of each shape. And the same for this star. It's a 5-pointed star. It's got 1, 2, 3, 4, 5 points. And then if you look at those lines of symmetry, they all cross at that same point right there in the center. So this first question or problem says to draw all the lines of symmetry on the tree shape below. So let's just look diagonally. If I were to draw a line diagonally across this, the two sides of that line would not be the same. They would not match. If I were to draw a line across the center in this direction, it's the same thing. The top and bottom do not look the same. However, I can draw a line straight down the center and my two sides of that line are identical, and that makes that a line of symmetry. The question says, how many lines of symmetry does the tree shape have? 1. Number 2, draw all the lines of symmetry on the X shape below. So we'll start with the most common line of symmetry, which is straight down the center. And you can see the two sides of this, they match and they're the same. Now, there are 2 more lines of symmetry for this shape. I'm sorry, not 2, 3 more lines. The second one is also the common one, which is just going straight across the center horizontally, so the top and the bottom match. Now, the other 2 aren't quite as easy to notice. However, if I were to turn my paper in this direction, it doesn't look like an X now, it kind of looks like a plus sign. And you can see on the plus sign, I can draw a line straight down the center of that plus sign, and I've got 2 parts on each side that match. And then if you do that for the other direction, again, it looks somewhat like a plus sign, and you can draw straight down the center, and again, those 2 sides, they match. So if it's hard to tell with those lines, you've got this first side, looks like this. It matches this side, it mirrors. Or those 2 sides are identical. So if we were to turn our shape back in the right direction, we can count there's 1, 2, 3, 4 lines of symmetry. So this shape has 4 lines of symmetry.